things that define when we use which equations.
And including like fine, which is like those piecewise.
I'm not gonna, what do you mean tell you where to use?
Give us just.
How do I know what the answer is here?
Okay.
No.
3.3.
Rules for differentiation.
Okay. Oh, I didn't mean to do that. Whoops. Hold on.
Let's start from the beginning now. Switch that recording. Take 2.
No, I don't. They'll live. Okay. So, up until this point, we've done basically the long way of finding a derivative. Remember, when you see the word differentiation, that means that we're finding the derivative. What is the derivative? It's the slope of the tangent. So this is what we've been doing. We started it back in chapter 2. I defined it at the beginning of this chapter, and now we get to use all the shortcuts.
I'm sorry for asking dumb questions, but I still don't get what a tangent is.
It's a line that touches a curve at one point.
Only 1 point.
Only 1 point. So let's say we have a upside down parabola. You have infinitely many tangents on a curve.
Yeah.
So we're saying just at 1 point, what's the slope of that tangent?
Oh, okay, it's not that much.
And the tangent tells us about, no, the tangent is something you should, like tangent and secant you learned in geometry, like when you have a circle,
Yeah.
a tangent. I mean, I know it was a while ago, but
I didn't understand.
When you have a secant, suppose the secant was negative inverse.
Dr. Meadows in geometry tests, you give like a term section. I get that all wrong.
so a secant
It touches it at 2 points.
goes through 2 points. So that's the difference between, so here we would have a tangent, and this line would be secant.
What was the term that was
Okay.
the negative inverse of the slope of the tangent?
Normal.
That's normal too.
Yeah. Okay, derivative of constant. So these are our shortcuts. Whenever you have a derivative of a constant, it's going to be 0.
What do you mean a derivative?
Okay, so imagine, remember all of these, whenever I say d dx, that just means take the derivative of something, which means take the slope. So imagine that I have a constant. Like here's a graph. Let's say I have y equals 3. So if I'm looking at 3 as the equation of a line, y equals 3, what's the slope of that line? 0. So I can have d dx of anything. I could say d dx of pi, it's 0. d dx of negative 1,000, it's 0. These are all just horizontal lines. Whenever you see a constant, it means a constant function is not changing. So if I said, what's the derivative? It's not changing, it's 0. Okay, so the slope of the tangent, well, it's a horizontal line, so the slope of that has to be 0. Okay?
So C has to be a number.
Yeah, C is any, it just says any constant. Constant can be, so C is any real number.
In this case, if you post these notes, right?
Yeah, I do. If I forget, just email me.
Okay.
What's the f in df over dx?
It's just saying your function is, f is just some function. So maybe my function, in this example here, f of x is equal to 3. It's just notation. Saying the derivative of that function.
Do you care if we include it or not? Or?
No, I mean, I'm not going to be, you'll see. You'll get used to the notation. Okay, this one is a big one. This one's really important. Okay? Whenever you have the derivative of x to the nth power, the formula for that we no longer have to use that big, long, h approaching 0 definition. Well, I shouldn't say no longer. We have the shortcut now, but here, all you need to do, take this, whatever the exponent is, that moves to the front, and then we have x, and then we subtract 1 from the exponent. So it's 5x to the 4th. So if I said, what's d dx of x to the 8th, it would be 8x to the 7th. Okay. If it were the derivative of x squared, it would just be 2x to the 1st, or just 2x.
Are they gonna do like 3 to the 5th, and then and then it's actually 3 to the 4th, and then
Yes. Okay, so you're asking like if there's like a combination of the two?
yeah.
That we actually can apply with the next one. This is the constant multiple. So here, that's exactly what you're asking. It's kind of like I can take that constant out in front. So whenever I have a coefficient, it just basically gets multiplied to whatever the derivative is. So if I use the power rule right here, what's the derivative of this? That's just going to be 2x. So then I just multiply the 4 to get 8x. So we apply that power rule and then just multiply the coefficient to the front.
So
Yeah.
you said that a coefficient is just multiplying the derivative?
Yeah.
Wait, I don't get how you got 2x.
Okay. So remember,
Oh, is it like 2x to the 1? Because it's 2 minus 1.
yeah, just here, let me give you a couple more examples.
Oh, I just started.
Okay, here. Let's say I gave you y equals x squared. So y prime, remember that's another way to write the derivative,
It's 2x.
is 2x to the first, or just 2x. Okay? So if I gave you x to the third, what would be the derivative? It would be 3x squared. So now, what if I gave you 5x to the third? What would be the derivative of this? Well,
15x squared.
right, so it's 5 times the derivative for x to the third. The derivative of x to the third, the 3 goes to the front, and I take 1 away from the exponent, so that becomes squared. And then just multiply. So that whatever this number is in front just gets multiplied to our result. Maya?
Okay, so for the example in the packet,
Mhm.
is it really 4 times 2x to the 1?
Yeah. There's a 1 here. I just didn't really
I was just
bother to put it because it's to the first. Okay.
Is the 2x from
It's the whole derivative of that
whole
thing.
derivative, not the, and the 4 is separate?
The 4 is separate. Now, eventually, I mean, I want you to think of it as just all at once.
Yeah, because you could do it all together.
You could do it all together. You don't have to like separate the 4. But there will be a time that you want to separate that.
Okay.
Okay.
So it would be 15x squared then?
That's what I had, right?
Yeah.
Okay.
Yeah.
All right, sum and difference.
Oh, I thought we just solved that. I thought that wasn't.
Okay, sum and difference. It's just like, it's kind of like distributing the derivative. I'll kind of put here, distribute the derivative. So you see the d dx out in front? That means to take the derivative. So I can actually distribute. So we're going to do d dx of 4. And then I'm going to do d dx of 5x to the third. So what happens when we do the derivative of a constant? That was 0. So I have 0
0
plus. And now let's apply. We actually had this exact same example.
That's why I was hanging.
So this is going to be
5 times 3x squared.
good. So it's just 15 x squared. Okay?
The first one is 0 because
Because it's a constant and it's a horizontal line. So what's the slope of a horizontal line? It's 0.
the line is y equals 4.
Yes.
Wait, I have a question.
Anytime you have a constant,
Wait, don't go on.
Okay, what is the first part of it? The 4 plus
okay,
5.
so if I take the derivative of a constant, I'm always going to get 0.
Right.
Okay? But if I take the derivative of x to the power, right? So it's x to some power. It's going to equal the power times x to the power minus 1. That makes sense? So those are really the rules that I'm applying here. And then the 5 in the front just gets multiplied to that derivative.
So,
Andrew?
Oh, could you, the other 15x squared, could you go down even more and make it 30?
No. Okay, so the question, that's actually a good question because with derivatives, this is just the first derivative. Later on, we have second and third and fourth derivatives, which would mean that you would keep going, but only if it tells you to. If it just says find the derivative, then you stop with the first time. Okay? Luke?
so if you had like x squared over 2, would you just think about it as if it's being multiplied by 1/2?
Minus 1.4. Throw stuff like
Okay. Well, okay, that's a good question because the next example has all of that, what you were just asking about. So if I'm finding the derivative of this, so I want to take the derivative of each part, and we'll get to the x squared over 2. I'll explain.
So you just x them.
I would think of the x squared as a 1/2 x squared, and the x over 3 as a 1/3.
Oh, that's
Okay?
How does that
So
indicate to?
So you end up with 1
because then I
times
take
x,
the 1.
which is just x. Okay.
okay,
That makes
are we ready to go through this one? Okay, the first part, 3x to the 4th. So I'm going to take the 4, multiply it, so it's going to be, okay. Not everybody at once. 12x, take away 1, so that becomes to the 3rd.
Wait, don't you just, doesn't that equal 0? Oh, that's if you're adding.
Okay. 3 gets multiplied to the 6, so it's minus 18, and it becomes x squared. Next, the 2 gets multiplied to a 1/2, so that becomes a 1, x to the 1st, right? 2 gets multiplied to the 1/2. Do you want me to write that
No,
out?
I got it.
I do.
2 times 1/2, and that'll be x to the 1st.
Wait. So it's not a half x, 1x to the first over 2.
Guys, you could do this 2 different ways. You could think of that as a 1/2 x squared, or you could do the x squared on the top and make that 2x over 2. Regardless, you're going to get the same answer. You're going to get that these cancel and you're just left with a 1x. Okay? The next one, what do we get?
Is it 0?
It's 1/3 x to the 0, but what's x to the 0? Just 1.
Wait, why is it x to the 0?
Well, this has a power of 1. Take 1 away.
What?
Wait, x to the 0?
Oh, we always have to take it away?
1/3 x to the 0. So
And then this will be plus 0. Or sorry, whoops. Okay.
Why is it plus 0 not plus 10?
What's the derivative of a constant? 0.
1/3 x to the 0 is 1.
So it's 12x to the 3rd minus 18x squared plus x minus 1/3. Okay. Are we okay with that?
Yeah.
I'm a little.
Wait, is that the answer?
That's the answer.
Oh.
If you
I'm-
were to write
Wait, we didn't have to
the
add
1/3
anything?
x, if you were to write the 1/3 x to the 0, like you did for the 2 times 1/2 x to the first, it would be 1/3 on the outside. Then in parentheses it would be 1 1x to the 0. I'm just trying to visualize it. Is that what it would be? Okay.
Okay, we're good?
Yeah, I get it.
So keep in mind,
Yeah.
like here,
It would be 1 on 4.
okay, so let's do the derivative of each part. So I have a 0 for the 3, minus, it'll be 6x to the 5th,
The derivative of a constant is 0.
right? And then plus
4.
4 over 8, and that will be x to the 3rd, plus 7x to the 0.
7.
So what does that look like when we're all done? We get negative 6x to the 5th, plus 1/2, no, half.
To the 3rd.
1/2 x to the 3rd, plus 7.
X. Oh no.
I get this.
Can we use this on the quiz or?
To check your answers.
Okay. But you want us to use the actual equation?
Yeah, there's one equation that you have to use that one definition,
Yeah. Okay.
but you can use it to check your answer. That's actually gives you a little advantage over whether you had taken it today. Okay, so now how do we find a horizontal tangent? So this is where we want to set the derivative equal to 0, because remember, horizontal means m is equal to 0. Before, we've done these problems before, just before we had to do the long definition with h approaching 0. Now we don't need to bother with that. We can just go right to what's the derivative for x to the 4th? That's going to become 4x to the 3rd minus, next it's going to be 2 times 2, so it'll be 4x to the 1st, and then plus 0. Good.
What does it mean though by set derivative to 0?
Because it, notice I'm asking here for horizontal tangents. A horizontal would be m equals to 0
So when do you put that in?
right now. So this right here,
Will be 0.
that's m. So we want that to be equal to 0.
Oh, okay.
Okay. Okay, what can we do to solve this? Factor out,
Factor out of 4x.
and we're left with?
X squared minus 1, and then you factor, that's a different
Now you
squares.
can do, yeah.
X minus 1, x plus 1, so x equals 1 and negative 1, and 0.
Yeah.
Yay!
This is, I should say where. I should have said find where the horizontal tangents to the curve are. They're at x equals 0, negative 1, and 1.
Did you say m equals 0?
Yeah, m is 0.
So 17 will be due tomorrow.
Yeah, I'd like you to start the homework that's from 3.3.
Or will we probably not be definition?
We'll see. That was the easy part.
Can you go back to the
Now we have the product rule.
Oh man, it's starting to look like logs.
Yeah.
And I
I
don't
wouldn't know
like
if you
loggers.
Uh, She's making me uncomfortable.
Girls. You laugh about stupid things and cry about stupid things.
Are you still ready?
Yeah.
Sorry.
How are you, girl? Yes.
He was your special.
Stop.
Girls will see the truth.
Okay. Product rule.
They care about stuff. The real. And the me. Alex. Where did I notice?
Okay. So, so with the product rule, sometimes you can just FOIL and multiply this out and it's fine, but there are going to be times when we cannot just multiply it out. We have to apply what's called the product rule. So let's say we have two things multiplied together, say u and v. So this is the product rule here. It's basically you take the first times the derivative of the second, so I'll put like second prime, plus the derivative of the first one times the second. They have theirs out in a slightly different order, but that's basically it. You take the first one times the derivative of the second plus the derivative of the first one, keep the second one the same. That's the rule.
Sounds like the
So it's the
cosine
derivative
2%
of both or division?
Okay, so here, let's just take a look. Here's an example. Let's say this is u, and that's v. Okay, so just looking at what u and v are, what would be u prime? Just look at 2x plus 1. What's the derivative of that? What's the slope of that? 2. Right? It would be 2x to the 0 plus 0, so that's just a 2. If v is 3x minus 5, what is the derivative or the slope of that? 3. Okay, so let's use this formula where, okay, so we want the first, so that's going to be 2x plus 1 times the derivative of the second, that's v prime. So we put 3. Plus, then I'm going to take the first part derivative, that's 2, and now multiply it by the second, 3x minus 5. Now we're just going to distribute and combine like terms. So it's going to be 6x plus 3 plus 6x minus 10. So we get 12x minus 7.
That's the answer.
Yeah, mine.
So how do you know that v prime is equal to 3?
Yeah, I was confused with that.
So how did we find the derivatives earlier? It's, think of this as 3x. There's two ways you could look at this. Just look at 3x minus 5. Imagine that this was the line y equals 3x minus 5.
Oh, then the
What would the slope be? 3.
The derivative of the constant, like the negative 5 and the 1 get canceled out because
Yeah.
the derivative is 0, right?
Right. So the constants, whenever we have constants, they just go away. You could apply that
You know
power
you're
rule.
supposed to fill in 1 for x to find the u prime and the v prime.
How did I know which part?
You filled in 1 for x in u and v to find u
Oh,
prime.
that was just, you could think of this as 3x to the first, so it would be 1 times 3, so it would be 3x to the 0. So the x to the 0 just goes away. That's all you don't need to put this in here. I think it's easier to think of it without.
It's actually making a lot of sense. It's just the equations look intimidating.
They are a little intimidating. Quotient rule. Okay, this one. Okay, so the quotient rule is more difficult than the product rule.
I have a question.
And I have, so this is kind of a little silly rhyme, but it actually does help you to remember the rule.
329.
Okay, so
Who used that? I'm just curious. Who used that?
I did.
Low G.
did it work out for you?
Yeah, I did.
What?
329. Low D. High. Take high. It's like a trick.
Okay, so what is this saying here? It says,
Low D, high, take low. Plus the line is below.
okay, think of whenever it says low, it's talking about the denominator. Whenever it says high, it's talking about the numerator. And then D means derivative.
Low D.
Okay.
High D. Low. Cross the line and square that.
Okay, so it means if it says low D high, it's going to be the denominator. I'm going to write this out in words so those of you that need a little like translation, if you will. Denominator times, it says D high, so that's going to be taking the numerator and taking the derivative of it. Is it okay if I just put the little tick mark here just so you know that's derivative? Then it says take, so that means minus. High, so that's the numerator. d low, so that's times the denominator's derivative.
Then square.
And then cross the line, so that means all of this is over the denominator squared.
That's not so bad.
It's not. So the rhyme sounds a little silly to start with, but trust me, most students end up thinking of it anyway. It's like low d high, take high d low, cross the line and square the low. But it helps you to remember, because students often will get the top part switched around, and if you switch that, it makes the derivative obviously incorrect. So think of,
Don't tell Dr. Powell and Mr. Schwall about this rhyme. They might get it.
all right, d dx of x minus 4 all over 2x.
Are we gonna ever have like x squared
I
and
said
stuff like this?
Dr. Powell and
So I
Mr.
think the
Schwall
product
about
would
this rhyme.
rule would get very hard.
It gets harder. I'm trying to, it's slow.
Do students often
Okay, let's do this example. So the denominator is 2x. So low, d high. Now, if I look at this, this is a 1x minus 4.
So it's just x.
So it's just, no, it's just 1.
Oh.
Think if you had y equals x minus 4. What would be the slope of that? 1. Minus, then it's the numerator, or when I say take high, that's x minus 4. D low, what's the derivative of the bottom? If you have y equals 2x, it would just be 2.
What's the derivative in this case?
All
Slope.
over
Okay.
4x squared.
All over, right, and you could square that. Okay, so it's going to be 2x. Let's distribute, so that's going to be minus 2x and then a plus 8. All over 4x squared, and then just look to see if you can simplify that. So the 2x's will cancel. I'll get 8 over 4x squared, which is 2 over x squared. Luke, do you have a question?
Yeah, you in the phrase and what you how you translate it's the denominator times the derivative of the numerator first, but then in the equation above it shows v times the denominator. I mean the derivative of the numerator first.
No? Well, yes, but u is the numerator. This is the same formula. This is just the rhyme for it.
How do we have?
U is the numerator and v is denominator.
How is the denominator of 1 in the derivative?
No, the derivative of the numerator is 1. Y equals 1x minus 4. What happens to the minus 4? It goes away. What's the derivative of 1x? Here, Andrew, think of this. Think of it as y equals x minus 4 and y equals 2x. What's the slope of this line? No, 1. Yeah, and what's the slope here? These are the derivatives. You can also use the rules that I was just explaining.
Actually, no, I think I get it.
Okay, let's try another one. Let's try another example here.
Can you go up and try to do this like
Yeah. Okay. We're going to do the quotient rule. So it's low d high. So it's the low or the denominator.
X minus 1 times 2x plus 4
Good. 2x plus 4.
minus x squared plus 4x. And then
What's the derivative of the bottom? It's just 1. All over x minus 1
when did these
squared.
It's denominator squared. Oh yeah, you're right.
Okay, so let's just go through. Shh, guys, there's too many side conversations.
for the derivative of the denominator, why is it?
It's 1. Okay, so think of this as being the line y equals x minus 1. What would be the slope of y equals x minus 1? Just 1.
And the slope of the numerator is
The derivative of the numerator, we would do the 2x to the first plus 4. Remember, because this would be 4x to the 0, which would just
so
be,
when I don't have just a normal outcome.
then you have to do that power rule.
Okay.
Okay, how does this simplify? Well, we do have to do FOIL in the numerator, so it's going to be 2x squared
plus 2x
plus 2x minus 4.
minus x squared minus 4x all over.
Don't, in here, just leave the denominator as x minus 1 squared. It's best to just leave those in factored form. Sometimes they'll be able to cancel, but usually they won't. So I get x squared minus 2x minus 4, which does not factor, so it's fine that we just left the denominator the way that looks. Yeah.
Back there for a second.
Mhm.
How do you get the n equals 1 and n equals 2 for the previous quotient rule blocks?
Right here? This one?
No, n equals 2 rule blocks. I've read above it where it's n equals 2 and n equals 1.
That was for this, that was for this one. Yeah, what's the slope of y equals x minus 4? What's the slope of y equals 2x? Yeah, Preston.
What are we actually taking the derivative of with all these? 'Cause it's not of a point.
You're saying, okay, guys, this is some type of rational function, right? I could tell you right away, just looking at this has a slant asymptote, y equals x. I also know that it has a vertical asymptote at x equals 1. Okay, it's a rational function, so I know it's going to have like multiple parts to it. What we're saying is that this is the formula for the slope at any point other than 1 because it's not defined there. So if I said to you, what is the slope of this curve when x equals 0, could you figure out what that is? It's -4. So I know my slope is -4 when at a certain point. It just means that this is the formula. This is the formula for the slope of the tangent at any x value. So if I can come up with the formula for this slope of this tangent, this is going to come in very handy when we are working with the applications, like when we get to velocity and acceleration and things like that, because there is, you'll see an overlap with the physics that we learned. This will always work. Andrew?
Yeah, we do. Because we dismissed it 2 times. We leave it 2 times, so we have to go.
Okay, bye. So, oh, you have, I'm sorry, Matthew.